So, the quick summary, the kind of high-level picture of what I'm talking about is, in 2 sentences, we sellotaped Raspberry Pis to our public meeting room walls in our building to allow people to work out what was going on in the rooms. Okay, and I'm going to spend the next 10 minutes telling you in a bit more detail about that. So here's the problem, right? Don't know what your organisation's like, but we've got an Outlook calendar, and we use the Outlook calendar to book meeting rooms for events. So all our rooms in the computing science department have an email address, and you kind of email the room and say, you know, or invite it to an Outlook event and say, I want you to be in my Outlook event. Well, really, I want to be in you, join the Outlook event, and you kind of send an email and it gets sent off somewhere, and a nice secretary somewhere will say, okay, and then you've booked the room. But what happens is either the big professors pull rank and cancel your booking so they can have the room, that happens occasionally, or people book a room for a whole day when they're only going to be in it for 10 minutes. Okay, and it's really wasteful resource. In fact, in our department there are, let's think, probably about 150 people, PhD students, members of staff, professors and so on, right? And there are only 10 public meeting rooms, so the rooms are very what's the right word? Overutilised, is that the word? Or under-resourced, yeah. So what we're trying to do is come up with a way of quickly finding out whether a meeting room's in use without actually having to kind of poke your head around the door and have a look. So this is the Raspberry Pi Internet of Things solution. And if I were to pop up my visualizer here, you can see what we've done. So the opportunity is very obvious, because the university at the moment is investing £1 billion apparently in upgrading the campus. So they've just bought the hospital site down the road there, the old Western Infirmary, and they're upgrading it. And apparently this is going to be the largest civil engineering project in Scotland since the Commonwealth Games, which was, when was that, 2014, so only 2 or 3 years ago, but there we go. This is going to be a really big project, and as part of it, they're going to upgrade the campus to make it smart. So we're going to have a smart campus at the university, and my idea was to try and prototype the smart campus embedded sensors with Raspberry Pis. This is a very kind of quick and hacky, dirty solution to do it. Of course, what's going to happen is somebody big like IBM or HP or something like that is going to come in and sell us a massive solution for loads of money, but we're just going to prototype this kind of small-scale solution for now to see how it works and to get some kind of user feedback so we know what we want when we buy the big solution off the big boys. Okay, so the solution is, if I open the box, you can have a look. Admittedly rather low tech. This is a Raspberry Pi, original Mark 1 Raspberry Pi board. You can get these things off eBay now for about, £5. Okay, or you can buy yourself a new Raspberry Pi 3 for 30 quid, or if you buy the right issue of the Pi magazine, there is a Raspberry Pi board, a single board computer on the cover. Do you remember in the old days you used to get discs on the cover of computer magazines? Now you get computers on the cover of magazines. Isn't that wonderful? So you could just pick one of these up for nothing effectively. Okay, and we've just used the I2C bus and the GPIO pins on the Raspberry Pi to attach a few sensors. This prototype board here is actually falling apart. Let me just put the insulation tape back in place and you'll be able to see the sensors. Wow. So at the moment, this one's got 4 sensors on board, I think. There's a temperature sensor here, okay, and a light sensor. There's an IR sensor in there for motion as well, and down there there's a microphone, and that's not recording an audio stream, but just the kind of ambient sound level. So we put one of these Raspberry Pi boards with the sensors attached in each of the public meeting rooms, and we attached a long Ethernet cable to it. We could probably do this wirelessly, but we just do Ethernet. And also the Pis are powered with USB, so we attached a USB power brick to a wall and plugged it in there as well. So it's a bit ugly. We could probably make that a bit neater, but this is our kind of low-tech, low-cost solution. And putting one of these things together, buying the sensors and assembling it all was a very quick and simple solution. So basically all the equipment in there costs about 25 quid altogether, and it's very easy just to stick it on a breadboard and put it all together. So we've got each of the rooms now with this kind of sensor enablement, and then we just have a simple web browser user interface, which allows you to go and have a look and see what the state of each of the rooms is. So this is the kind of map of our building here. This is the Sir Alwyn Williams building, which is just down the road, and this is a bit further along that way, the Lilybank Gardens rooms there. And what you can do is you can go and have a look at an individual sensor. So I have a look at this one here. Let's see, this one's happy.
Yeah.
There we go. Oh, sorry, you can't see it. Well done, well done. I'm going to get HDMI and then you can see it. Good. So this is one of the meeting rooms here, hopefully. And you can see the temperature and the light. Nobody's been moving in this room for the last 3 hours, so obviously, you know, people were in a meeting there a while ago, but there's no one there at the moment. And we do have a problem with mice, which sometimes trap the sensors, but never mind. And there's also a measurement of the sound level as well. So this is kind of instantaneous data. And you can imagine a kind of quick and dirty solution where you say, right, I'm just going to go and have a look at this meeting room, see if anybody's in it. And you go and check to see the motion sensor or the sound sensor to see if anybody's there. Okay, and if they're not, you can go in and kind of camp out in the meeting room, and you don't need to worry about the Outlook calendar, squatters' rights and all that. But really, you can do far more than this with the Raspberry Pis, because Raspberry Pis are very powerful, capable computing devices. Okay, so on your Pi you've got a gigahertz processor, you've got maybe half a gig of RAM, and you've got a full Linux operating system. Okay, so what we're actually doing on the Raspberry Pis is some amount of edge processing. That's not happening here. So here the data's being collected and it's just being sent off to a central server, and the data's being stored on the Amazon S3 service. Okay, right. But actually what you can do is some kind of machine learning, and this is what we're prototyping down here. So you can run a simple predictive algorithm, a support vector machine to be precise, on each of the Raspberry Pis that streams in the sensor data and applies the predictive model to tell you whether or not the room is occupied or free. Okay, so the Raspberry Pi is doing that computation itself locally. And then you can go and query the Pi, and instead of saying what the sensor readings, say, is there somebody in the room? And it can tell you, okay, based on its trained machine learning model, whether somebody's in the room or not. Okay, so now what we can do is, and this is still to be developed, this is future work. Now what we can do is we can get our smartphone app, right, and we can say, take me to a meeting room, okay, and it knows where you are, it knows where your nearest free meeting room is, and we've got indoor turn-by-turn navigation because we've got Bluetooth kind of direction-finding sensors around the building, and your smartphone will just direct you to the nearest free meeting room. Ha-ha, isn't that wonderful? So the kind of Outlook calendar mechanisms are now looking very last century indeed. The next step, this is slightly sci-fi here, but we've got some robots on wheels. Okay, right, so what's going to happen is all the fleet of robots are going to be by the front door, and then you're going to come in and say, hello, I'm in a meeting with Jeremy, and then the robot is going to drive you, or at least kind of direct you, you'll follow the robot, to the meeting room. And this is going to work really, really well because the robots have got Raspberry Pis on them too, okay? And the idea is that the robots are going to do kind of navigation through the building, and they can offload computation as they go to Raspberry Pis that are embedded round about the building. If they become overloaded with their local computation, they can do the kind of route planning and the collision avoidance and so on. Okay. Interestingly, what the university wants to do is not just put these kind of sensors in meeting rooms so hapless academics can find free rooms, but also in lecture theatres, because it's very interesting to try and correlate ambient environmental conditions with learner performance. So it doesn't look like anyone's fallen asleep here yet, but you can imagine at 9 o'clock on a Monday morning, when I'm droning on to 150 students about the wonders of the C programming language, lots of them are kind of dropping off falling asleep. And what we can do is check to see whether it's temperature levels or kind of light levels or CO2 levels, things like that, that correlate with student attentiveness and performance in lectures. There's lots of research going on in this line in the kind of social science domain as well as kind of engineering and computer science. And ideally, what you can have is a smart campus where the room conditions are kind of tailored and optimized for the kind of thing that's happening in that room. I'll just say one more thing, then I'll shut up. Right, okay, so imagine this, right? Imagine the kind of the smart campus, where all the students have got the app on their phone, right? Okay, and it's got the lecture timetable on them for the day. And you turn up at 5 to 9 and you don't know which room your lecture's going to be in, but because your app's on your phone, the smart campus knows that you're here and you're going to attend the lecture. Lots of students won't. They'll still be sleeping off the weekend activities perhaps, or maybe even doing their part-time job in Morrison's or whatever it might be, and they won't be at the lecture. Lecture attendance towards the end of the semester peaks at about, bottoms out at about 25%. Okay, so 75% of the students are AWOL, right? So what's the point of having a massive lecture theatre if there's only going to be, 10 students in it? So we can do lecture room placement on demand and shut down whole buildings for the day because we know that there aren't going to be any students in them. So rather than kind of block booking that lecture room for the whole semester, we can just say to students, bing, today your lecture will be here, and they follow their phone, they attend to the lecture, and they sit down and fall asleep. Great, isn't it? So the idea is with the smart campus, we can use embedded sensors, wayfinding, navigation technology, and some kind of embedded intelligence, machine learning intelligence, and so on, in order to optimize room utilization and kind of personal performance and productivity in those rooms. Thank you.